plus 0 is equals to 7. X is equals to 7. Right? It's the same thing you get. So it's just as simple as saying when the minus 2 comes over to this side, the minus change to plus. So if it's plus that was here, if the plus is coming over to this side, it becomes minus. So that's it. That's how it works. All right, let's continue. The third one says C is positive and negative. So I can say C is equal to a positive value and a negative value. It's actually no value. That's 0. And when you say a set has 0, we can say the set is empty. This is what? An empty set. So we can say C is equal to 0. There's nothing happening in there. All right, let's move further. Then this other one says X is equals to, X is the set of X such that X is a letter in the word correct. So let's spell out correct. C-O-R-R-E-C-T, right? That's what is here. Now, how many letters or alphabet do we have in correct? This one is 1. This is 2. This is 3. Now, I won't count this because I already counted this. This is 4. I will not count this because I already have C here. And this is what? 5. So I will say D is equal to, I'll draw my bracket, C O R E T. And this is the solution to that. So when you verify from what they got, you see it. So that's it. So basically it's quite easy. It's very, very easy. Sets is one of the easiest branches of mathematics. Now let's go to exercise 1.2. It says write this set in a set builder's form. Okay, let's attempt that. Now A consists of letters A, B, C, D, E. Now remember, I will say a set is what? It's a well-defined list, right? A well-defined list of objects. Now we need to define this list of objects now. So I can say, I have to introduce what? A variable. And I said that variable I'm going to use is going to be X. I can use Y if I like. So I'll say A is equal to A is a set of X such that X are alphabets that appear before F. The same thing here. So that X appear before F in the alphabet. X are alphabets that appear before F. The same thing. The same thing. Back and forth. So what we are listing here is from A down to F. But this notation now, this is what? The builder's form. Now we have let B equals to 2. This is, as I said, this is the tabular form. 2, 4, 6, 8. Now from here, what is the characteristics? These are what? Even numbers. So I'm going to use Y. So I'll say B is a set of Y such that Y are or is even numbers. Now if you look at this, you have 2, 4, 6, 8. Remember from by definition, it said a set is well defined. Now I need to define it such that I narrow it down to the point. These are all positive numbers, not negative. So I can say B is a set of y such that y is or y are even positive numbers, or even and what positive number, and that's how they got this. Are we getting it? Let's see consists of countries in the United Nations. The same way, you say C is a set of, I can say Z, such that Z, then you define your what? Your list. Make it a well-defined list. What they use here is X is a country such that X is in the United Nations. It's quite simple. Very, very easy. Now, a set could be finite and it could be infinite, or finite or infinite. And what we're saying here is that a finite set is that set that has the element that can be capped off. What I mean is the elements in the set, they have a beginning and they have an end. That's a finite set. While an infinite set is a set where there's no end, there's no limits to it. It keeps going and going and going, right? Now, for example, we say of the year. Now, you will agree with me that this set is a finite set. The months of the year starts from January, ends in December, right? So this is finite. There's a beginning and there's an end. If I say A is a set of Y, such that Y is the integer between 0 and 100. Remember, this is the builder's form. So what I'm trying to say here is A is equal to 1, 2, 3, 4, dot, 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 100. This has a beginning and also has an end, right? So this is a finite set. But when we say infinite set or infinite set, we're talking about a set that does not have an end. The end cannot be determined, right? Now you agree with me that this is infinite. Now what we are, this is a builder's form of set. So if we want to break it down into the tabular form, what we are saying here is A is equal to even numbers 2, 4, 6, 8, 10, 12, 14, 16, dot, dot, dot. That's how you get to 10,000, dot, dot, dot. It's infinite. You get to 1 million, 1 zillion, because here it wasn't capped off. It wasn't capped off. If they had told us Y is the even numbers between this and this, you know, we have the beginning, you have the end, then it's a finite set. But this particular set is what? An infinite set. All right, now the next concept we want to talk about is the element of a set. Now, with this, we have a notation for it, and is this symbol is E. It's like an E. You know, the traditional E is like this, but this one is a bit long, like this, like the euro sign. It's long. Now this means element of. Now what we mean by this is, let's take a set A whose elements are A, E, I, O, U. Now we can say in the builder's form, A is a set of X such that X is the vowel alphabet. Alright, now this is the builder's form, this is the tabular form. Now we can say that A is an element of A. This A here. What we are trying to say is that there is A in A, or let me just say E is an element of A. We are saying A contains E, right? Now if you look at this set now of vowel sounds, or vowel alphabet, there's no F there, right? Or there's no B. So if I say B is an element of A, this is not correct, because B is not in this set. So what we'll say is B is not. So when we stroke out that long E, what we are saying is it's not an element of that set. So I can say B is not an element of A, meaning A does not contain B. Okay, now what about equal sets? Now equal sets are sets that have the same elements. So if I say let's say set A is equal to A, E, I, O, U, we put commas, and I say set B is equals to E, A, O, I, U. You will agree with me that the elements in A are the same in B, right? Elements in set A are the same in element in set B, regardless of the arrangement. This is A, not 9. You know, regardless of the arrangement. So we say A is equal to B. The reason is because the elements here, you have E here, you have A, you have I, you have O, you have U. So the elements in A are the same elements in B. Automatically we say A and B are what? Equal sets. What about null sets? When a set is empty, we say it's null. For example, you say A is a set of X such that X older than 200 years. Now you will agree with me that in Nigeria we don't have anybody that's up to 200 years. So what we say is that this set is empty. It's a null set. It's an empty set. There are no elements in such a set.